To the
Oh,
technical version group.
take it away, Ike.
Hi, this is Ike Ellis, and welcome to the Technical Immersion Group for San Diego. Actually, more than San Diego now. We're starting to develop maybe a larger presence, and so we should probably remove the San Diego from our title coming up with it. But what we are is a technical book club, and without saying much more than that, that pretty accurately describes us. We pick a book and we read it. We read the same book over the course of several months. So if it's a 300-page book, we might divide it up into 100 pages and read it over 3 months. What we do in addition to that is we typically bring a subject matter expert, one, two, or more subject matter experts, to kind of lead the track and mentor us so that as we have questions, we can ask them and get answers to them. So the main problem with reading a book is that the book never answers back to you. So if you read something the author's trying to present and maybe you don't agree with it, or you wonder if that's really true, or you wonder if there are alternate ways, this is the kind of value that the mentors provide. So as you go through us and read this book with us, we encourage you to ask those questions that you typically just dismiss because the book won't respond. So that's it. You do need to kind of keep your commitment to us, though. We do this all for free, and we only ask for a few things in return. The first thing we ask is that you actually read the book, that you participate with us, and that if the book or the instructor has any homework, that you actually do the homework. We don't grade. There's no incentive other than you're being respectful of our time that we've donated, and you've agreed to participate with us. And that's where we get all of our satisfaction in putting these meetings on. If you have questions and we're not online and you'd like them answered, you can go to meetup.com. There's a discussion tab that we monitor, and you can post your questions there. Now with that, I just want to take a brief moment to introduce our mentors. That's what we call the people that read the book with us and help us along. This group started many years ago now, I think, or over 4, maybe 5 years ago, with 3 of us, Scott, Brad, and me. Scott Reed is a Azure MVP alumni and a popular code camp speaker, and has been leading tracks. Everyone really enjoys it when Scott leads the track. He's also my business partner, along with Brad, who's the next mentor. Brad Cunningham is a C#, which I think got renamed to maybe a developer tools MVP, and has been one for many, many years. He's been on popular podcasts and has spoken at conferences, and he always brings just an unparalleled level of knowledge to all of the discussions. One of our newer mentors is Jim Count. Jim is just a pure, raw, great developer and has worked on projects for many, many large organizations in San Diego and the outlying region. Jim is a good friend to all of us, and we're super grateful that he volunteered his time to be with us. He really answers questions that no one else seems to be able to answer. And with that, I wanted to introduce you to our newest mentor and our newest track leader, who's going to be leading this track. This track is titled Business Analytics with Python. And so we're going to tackle kind of 2 very hard questions at once. One is, what is business analytics or machine learning or predictive analytics? And 2, how do we do that in a very specific language, Python? And who's leading that track is Chris Bushin. Chris is a good friend to the other mentors, and we hang out with him and really enjoy his company. In addition to being just a phenomenal developer and an excellent technical leader. Chris leads a very fast-growing development team at a local San Diego company. He's taken that team from roughly about 4 developers to what appears to be upwards to 25 developers, and growing every day. In addition to that, Chris writes code all the time. He's writing code at night, he's writing code on the weekends, he writes code constantly. And one of the areas that has piqued Chris's interest lately is machine learning and predictive analytics. So Chris, in his words, he thinks that you can forget about self-driving cars, machine learning that will change the world. And he's got a deep and abiding passion for that topic. So he's chosen our books, he's planned our discussions, and we're really excited to have him join us and And I personally am excited to learn all that I can from him. So with that, Chris, you're on. Do you want to talk about this track and what you've got planned?
Yeah. There are two books that I've been interested in lately about machine learning. One is Machine Learning in Python, which is a very practical approach, and the other one is Machine Learning, a algorithmic approach for people who want to dig a little bit deeper. Um, so primarily, practically speaking, machine learning is the use of statistical models on data sets to predict unknown results with an existing data set. So what does that mean? That means that you take an existing set of data and you might have some values that you've already seen before, and the idea is to predict new original outcomes of data once you have an existing data set. So there's two types of problems that we'll be covering. Regression and classification. Regression is for stuff that might be on a number line, like temperature or average movie review. And classification is groupings that you might cover, such as true or false problems like has diabetes or not, or red, green, and blue, or something along those lines. So from there, we also have different types of machine learning models. So supervised and unsupervised models. Supervised meaning that you have a set of data and you learn that set of data and you make predictions based off of that data. And unsupervised meaning that every new instance of data that you get actually gets incorporated into your model and you grow your knowledge as you go. So supervised, you may not grow your knowledge as you go, or you might have to recalculate your predictions, where unsupervised just learns and picks up where you left off. The next kind of thing that we'll be covering is algorithm styles for machine learning. And so you might have a single machine learning model, or you might have an ensemble method. A single machine learning model is the use of individual instances of a model to make predictions, and an ensemble is to take large groupings of models and use them to make a consensus on a prediction or have a heuristic around which models to use when you need to use them. From there, we're basically going to try and figure out how to measure the success of those algorithms. So you may think that accuracy is a good thing to use when making predictions, but it actually isn't. And in statistics, accuracy is a very simplistic method. And what you really want is the AUC, or area under the ROC curve, ROC standing for radio operator characteristic, which was developed in World War I or II. And basically the idea there is that you want to identify false positives and false negatives and use them in the calculation for what you think is a good model. Finally, we will also include use of common Python algorithms or libraries, NumPy and Pandas and sklearn. NumPy and Pandas are ways to organize your data as you import them into sklearn, which is a library full of great machine learning models. The book that we're going to cover is for people that want to cover practical use of machine learning algorithms, and then the other book I mentioned by Stephen Marsland is more for creating your own machine learning algorithms. Finally, I wanted to talk about the UCI machine learning database, and in there, UCI has actually created a number of data sets that can be used for creating papers about their results and also sharing the data that can be used for machine learning. And so one of the most basic examples is the iris data set, which is predicting the type of iris flower based off of measurements of the flower, all the way to wine quality and how good wine is based off of the chemical measurements. So in general, we want to make sure that we can utilize a set of data, and the easiest way to get that set of data is through the UCI machine learning data set. So we have a plethora of data. We also have some great practical uses of machine learning. And finally, if people want to dig a little deeper, I have a recommendation for a book for writing your own machine learning models. But I don't intend to cover writing your own machine learning models in this course. So we would typically stick toward working with practical uses of this.
So
that's it.
Right on. Thanks, Chris. So for our class, for our course here, we're going to use this book here that I should be screen sharing, Machine Learning in Python, Essential Techniques for Predictive Analysis. And I haven't dove all the way into this book, but I think, Chris, you're probably familiar with it. This should be a pretty good kind of introduction level book for someone who wants to get into machine learning, right? And it's mainly in the context of Python. Is that pretty accurate?
Yeah. And what's great about that book is the use of NumPy and pandas and sklearn. So as opposed to the other book I mentioned, they actually use the commonly used libraries for using machine learning in existing applications or new applications. And like I said, NumPy and pandas are ways of organizing data, and then sklearn is ways of making predictions based off of that existing data.
Cool. And then the other book you mentioned, which is kind of a deeper dive here, is this guy, right? Machine Learning, an Algorithmic Perspective.
Mm-hmm.
This one's quite a bit more expensive. It looks like you can rent it for $30. But it looks like the new book is actually about $80. But this this book is not Python specific, right? It's more.
Python's actually done in Python, but what's neat about this book is that they actually write all of the machine learning algorithms from the ground up. So instead of using sklearn, if you really were interested in digging deep into machine learning, this is the way that you'd create the statistical models that you'd use to make the predictions. So kind of a different thing than what we're going to be covering, but I wanted to mention it to anybody who's interested in, say, neural networks, which are not covered, because there's a trade-off between computational complexity and practical use. And neural networks are actually very expensive to use, and so that's typically why people don't mention them in machine learning books. And so I just wanted to bring it up because this gives a great way of looking into how those more advanced, more complex systems are built from the ground up.
Very cool. And then we also mentioned I think this was probably on right when I was first screen sharing, the UCI. It's a local university, California, Irvine. The biggest issue, it seems, with getting into machine learning is really getting a data set of any volume to be able to perform your algorithms and see how they work out. You really need large volumes of data. So as Chris mentioned, this UCI machine learning repository, they've got quite a lot of data sets. I actually remember this was quite a while ago, and maybe we can get a little bit into your background with machine learning there, Chris, but I think, do you remember maybe 6 or 7, maybe even longer than that, 8 years ago, Netflix did a competition. They did a competition to improve their recommendation engine to say what you would watch next, and they dumped all of their data that they had. They anonymized it, but I remember that was one of the first big data sets that I saw. That was probably 8 or 10 years ago, and it was all just text files, and it was anonymized data of Netflix users watching behaviors. And I think it was like $1 million prize or something if someone could come up with a better algorithm. I think somebody actually won it, but I think it was a research group at college. I don't know if anybody else remembers that, but I remember that was one of the largest data sets I was able to get my hands on that long ago. And I think the other one I see used a lot is weather-based data. I think the National Weather Service dumps a fair amount of their data, their temperature sensors. And so you had mentioned there's some problems that are along a number line, like weather and temperature. What did you call those types of problems?
Regression problems. So
Right.
regression problems are on a number line, and then stuff like red, green, blue, or aardvark and antelope, those are classification problems. And they're very different problems, but there are statistical systems that can predict either one. We just have to be aware of which ones we're using.
Very cool. So you want to tell us a little bit about what got you into machine learning, kind of what your background is with the topic?
Yeah. So in the past, I've worked with machine learning as my master's thesis, and so I did. My thesis was on computer vision and improving computer vision systems, as well as many of the classes that I took were spent on learning such algorithms and statistics. I actually opted to take every single elective, no matter the teacher or the difficulty of the class, to focus on machine learning through my master's. And I've been using it going forward in my position where I am now as the director of software development. So I've been very careful to continue developing my skills in machine learning and using that to write papers and things along those lines.
Very cool. So I'm interested to know what your thoughts are on the maybe the more practical uses of machine learning for people in the software industry. So obviously there's going to be some specialized roles where they're doing scientific computing, that sort of thing. But in the general cases, one thing I see, and I don't know a whole lot about machine learning, maybe this doesn't fall exactly into that case, but one thing I see a lot of is people wanting to do recommendation engines, something like Amazon does. Any kind of e-commerce site wants to do a recommendation engine, or they want to do kind of a big data analysis on their users' habits and make some predictions. Is that something that would fall under this category? And what are your thoughts on that? Is there kind of well-solved answers to that?
So it's interesting. So there's a little bit of experimentation because the different statistical algorithms are used to make those predictions. So you need to find out what the best algorithm is, and the way you do that is by setting up little experiments. Once you decide which algorithm you want to use, then you can drop it into an application that will then be used to do those predictions. But it's a good point that you make in the sense that if you want to recommend something to a user, as long as you have historical data, then you have a method for implementing machine learning to go forward and predict what new users or existing users will like to do or want to do. And so when you make recommendations, machine learning is a great way to identify what those things are and continue using them.
Very cool. Yeah, the reason I brought that up, I'm going to see if I can screen share again here. There's my first exposure into the software side of things here was this book. I was just looking on my shelf, actually. I think I've got it up here somewhere, but it was this book here, Programming Collective Intelligence, and I bought it kind of on a whim because I really knew nothing about it, the topic at the time, but it sounded very interesting. My particular use case was kind of search engine search ranking stuff, was crawling data out on the web and trying to do some rankings. But this is a pretty interesting book. It didn't get really deep into the, or at least at the time I wasn't smart enough to know whether it was deep enough into the data science part of it, but it did kind of go over the high level of how those common use cases of product recommendations, search engine rankings, online matchmaking, that was actually a particularly interesting topic, how the people like Match.com rank and perform algorithms against the people to try to match two people up. I thought that was pretty interesting.
Absolutely. And it's kind of worth mentioning at this point, sklearn is the most commonly used machine learning set of algorithms that are out there, but Google also just released their machine learning neural network called TensorFlow, which is also available in Python. So there's the possibility of using TensorFlow on some of this data as we go forward as well.
Just thinking about Brad's example of the recommendation engine, or even the dating one, right? It still feels like a classification problem, right? What they do is they look at you and say, is this person likely to want to buy this book, and then decide to like recommend it to you, or is this person likely to like this other person? So wouldn't you have to like go through like every person on Match.com and then make that classification? And is that where it gets hard, or am I just not aware of a better way to go about it?
There is a system for selecting groupings of data that are used in machine learning algorithms. And so a lot of the times you'll use what is called stratified sampling. And when you do that, what happens is you find common conditions and you sample from them. So you might have too much data to read into a machine learning algorithm. And one of the things that the book covers is the appropriate amount of data, or the appropriate computational complexity of your machine learning model to incorporate data to make it so that you're not waiting 20 years before your machine learning model has completed learning your data. And so I know that sounds pretty complex, but the idea is that with stratified sampling, you could potentially select a grouping of data that could learn your data without having to go through all of your data. But the book and with the UCI machine learning database, we're not going to we'll have small enough data sets to be able to do things using our full data set.
Yeah, that's an interesting point. It's some of this data that we're talking about is so large. Like you said, it may take 20 years, or it may take literally supercomputers to compute some of this stuff, right? I mean, when you were doing this research in college as part of your master's thesis, were you working with data sets of that size? Were you leveraging things like what the cloud has to offer? Were you doing local computing? I mean, is it realistic to have someone on just their laptop or their local machine be able to perform a decent amount of computational analysis on data this large?
Well, yeah, so again, that depends on the algorithm that you use. So in machine learning, there are different things. So for example, a neural network is extremely expensive to run. So you want to reduce the amount of data you use to a very small size. But with, for example, a support vector machine or a linear regression model, you could have huge amounts of data that you could read into the system and not have to worry about computational complexity. And so, like I said, one of the things that the book covers, for example, is the computational complexity of one algorithm to the next. And we'll be talking about that in further depth beyond what the book covers during the meetings.
So I think some of the stuff that I've read before is it's a matter of like how strong the signal is in the data, right? There's a very strong correlation, then you don't need a lot of data. And then where the big data comes in is they're looking for very weak signals, right?
Mm-hmm. So let me throw this example out at you that I'm sure everyone's had before, and tell me at a high level how they do this, or maybe what the better way to do it is, right? So I go shopping on Amazon, and I clearly over the last 15 years have a very specific Amazon profile, and they know a lot about me. But then I go and buy some outlier thing. I buy a kid's toy, or I buy a gift or something. And for the next week, it throws off my Amazon recommendations, right? And I've got to go in and tell it, like, no, I don't love Barbie dolls all of a sudden. Please stop recommending me Barbie dolls. Like, what's the deal there, right? Like, Amazon should be the smartest at this. That to me, to Jim's point, would be a weak signal amongst all the noise, right? Like, one time I bought a Barbie doll, but the rest of the time I bought booze and other man things, hammers and stuff like that.
Before we, just throw out Amazon, so before Amazon, 35% of Amazon's sales comes from their recommendations. So, one, it's a big department. Like, there are a lot of people that work there doing it. And two, they consider it, a huge source of overall profitability. So maybe maybe you really are into Barbie dolls and you just don't know it yet.
That could be. I didn't want to tell you guys that part, but that could be. No, I'm not. I'm not dogging Amazon at all. I think they do an amazing job, and I think if I look at my own purchase history, a lot of what I buy comes from. Let's see. I think I have an Amazon page up. Here, I'll share my screen. You can see whether I'm actually into Barbie dolls or not. So a lot of what I buy from Amazon comes from that frequently bought together section here, or even still customers who bought this item also bought this. A lot of my purchasing comes from there. I'll be looking at one product and then I'll go down and read reviews and then I'll look at these other products and maybe 3 levels in I'll go, oh, that book actually looks more interesting. In fact, I think they do a good job of, somewhere down here it says what other items do customers buy after viewing this item? So they have this thing of like, a lot of people looked at this book, but ultimately ended up buying a different book. And I definitely think a lot of my purchasing comes from there. But they do have this way for you to opt out and say, don't include this data point in my data set. And it seems like maybe the signal to noise there should tell them this is a total outlier.
Yeah. Well, I mean, so when you look at what Google announced when they announced TensorFlow, for example, they were talking about how many companies are currently not sophisticated about this stuff, and they said that they wanted to make sure that other companies start using more efficient algorithms and more intelligent algorithms for doing predictions, and that's why they actually released TensorFlow into the wild. And so going kind of off of that bias, you can imagine that there are different systems out there, and there's a different cost versus reward trade-off that you'll get with different algorithms. And we'll explore that a little bit in the sense that basically every algorithm that I've touched on during my education in machine learning has had a different cost-reward trade-off, and actually different data sets are interpreted better or worse based off of different algorithms. So it's a lot of experimentation and a lot of trial and error before you can find something that appropriately attacks the problem that you want to solve.
That's kind of like you said in the beginning there, that accuracy is not the key measure, right? You're not trying to get the accurate result, you're trying to get the right result, which maybe isn't always the same thing.
And that's what the AUC, which is it's commonly referred to, but it's the area under the ROC curve. In the war, basically the ROC curve was used to filter out the positive and negative matches between what are radar blips for tanks, enemy tanks. And so when you look at measuring this stuff, the idea is to find your, not just find your accuracy, but find the ratio of your positive matches versus your false positive match. Because if you have a false positive or a false negative, that can mess you up much more than considering getting a accuracy. So if you have a 90% accuracy, those false positives, that 5% of accuracy being false positives could actually be more detrimental than having a 95% accurate prediction.
Sure. Can't afford to blow up a friendly tank, right? That's the problem. Very cool. Well, this sounds very exciting to me. I'm excited to learn about it. It's definitely a topic I know very little about. For those of you that have been part of the TIG, you know that we've been doing Python for quite a few months now, and we're learning Python, the language, and then we learned a little bit about Python in the context of web programming, which is kind of one leg of the Python story, and then we think that data science is really another major component to Python's usefulness in the world. So we're going to dive in and learn a little bit more about that. Well, this sounds great. Hopefully this gives everybody a good overview of what they can expect with the group. As Ike mentioned in the beginning, if you haven't joined us before, you can check us out. If you just go to SDTIG.com, it'll redirect to Meetup, or you can go to meetup.com and search for the San Diego Technology Immersion Group, and you can join there. And we do a meeting in person as well. If you're in the San Diego or Southern California area, we meet in Carlsbad, and all the information is there on the meetup group. Does anybody else have anything more to add before we close out?
Is there any homework for this time?
No homework for this time. So this is just kind of an intro for those of you that have been in TIG before. We're kind of trying something new here and replacing our intro meeting with a quick recording, and hopefully we can just get started during meeting one. So for this time, before we meet in the next 2 weeks from now, maybe 3 weeks from now, take a look at those books. Hopefully purchase the book on Amazon.
Yeah, show it again.
I apparently pressed the hotkey to mute there, sorry. So the book that we're going to use for this track here is Machine Learning in Python, Essential Techniques for Predictive Analysis. You can get it on Amazon. Even on Amazon Prime, ships in 1 day, so you should be able to get it no problem. So pick up that book and start reading a little bit in it. We don't have any pages assigned yet. We'll have that in the first meeting if there's some specific reading, but it'll be good to get the book and get familiar with it. And then also take a look at the UCI machine learning repository here and just kind of click around, maybe download some of these data sets and start to get a sense of what data is there. Oh, one thing we didn't mention actually, what we're planning on doing is we're going to pick a single data set here, and everyone that's following along with us in the group will work on the same data and start to apply, probably start with the same algorithms, and then we'll start to change those up. And it'll be a little bit of a competition. We want people working against the same data, but to have different results, so we can kind of tweak some variables in our algorithm, maybe try different algorithms and see who gets, let's say, higher quality results. Remember, not necessarily the most accurate, but the most useful. So we'll discuss all of that in the first meeting, and we'll be live streaming those meetings as well, like we always do. So that should be good for now. Anybody else before we drop off here? I'll take that as a no. Well, thanks so much, everybody, for hanging out, and we'll see you in a couple weeks. Check us out on meetup.com to get all the details.
Thanks, Brad.
Thank you.
I'm excited.